So that's an overview of data virtualization and Denodo, and a customer that's actually using data virtualization in order to produce an outcome. What I'd like to do now is just give you a quick demonstration of the Denodo platform and how each of the different pieces fit together in order to produce an outcome. The place I'd like to start is talking about the different roles and responsibilities that an organization will have. You'll know yourself that across the organization, you'll have your developers, your business users, your analysts, etc. Each of these people will have different data requirements. They'll have different responsibilities, but ultimately it's all accessing the same information landscape. So for today's demonstration, we'll be simulating an organization, a small organization that has just 3 data sources. So we've got our Oracle data warehouse, but we've offloaded all of the data warehouse, the historical data warehousing information into a Presto cluster. And then we're also using a marketing web service for our campaign data. This means that we've got a distributed environment, an environment where the information we need is spread across the 3 different data sources. So what I will be showing you today is how we can use Denodo to connect, combine, and consume this data, specifically data around our sales campaign, the effectiveness of a marketing campaign, based on historical sales. So the place we'll be starting is with the Denodo developer, and they'll be using the Design Studio in order to build our data model. If we just take a quick look at the data model, just going back to that diagram about how Denodo works, this is really what we'll be doing, in that firstly taking a look at the base layer, the connectivity to those underlying data sources. Then we'll take a look at in the particular example I'll be looking for, I'll be going straight up to the reporting layer. But along the way, for a more complex environment, we might be building that semantic layer and those business layers. Each layer enriching, enhancing, and adding value to the data along the way without having to copy that data from that source system. So let's get started. Here's the Denodo Design Studio, all protected by security model. So I'm going to log in as the administration user. And you'll see that this is a web-based interface that allows the capabilities to be delivered across the organization to the roles that require it. When the Design Studio opens up, you'll see down the left-hand side all of the logical databases that are in my platform. And we can have as many logical databases as we want because they're just based on metadata. There's no physical infrastructure required. On the right-hand side is my canvas where I can drag and drop and start to build views. So the first thing we want to do is connect. And you'll see if I go to my database here, which I've arranged in different logical folders, we have all the different styles of data source that Denodo is able to connect to out of the box, whether we're talking about cubes or flat files, Hadoop systems, NoSQL platforms, of course, the traditional relational databases, or cloud-based, or even warehouses in the cloud, as well as software as a service applications and packaged enterprise applications such as SAP. Should there be a database or a data source that we don't have a specific connector for, there is also a SDK, a software development kit, to allow you to create a custom connector. So we do find that as long as the data source has a standards-based interface or API, then Denodo will be able to leverage the data in that platform. To create a connection, we can simply go New, Data Source, and choose the relevant data transport. We'll take a look at JDBC as the most common data source that we connect to. And you'll see here that we now get a form that we can click and configure rather than having to write code. So I can fill out the details in the form, choose the database adapter with all of the major vendors here, as well as the NoSQL on Hadoop vendors. And once we choose the relevant adapter, then we get prompted with the URL, transaction, and how we're going to authenticate. This gives us the option of specifying a username and password. So this is what will be used for each and every user that comes into the system, or we could actually pass through the credentials from the consuming application if that was capable of doing so. I'll take a look at the connection that I created earlier to my Oracle system. You can see here is my Oracle system. It just looks like the standard client connection. I can test my connection. There we go. So now I'm connected. The next thing I want to do is actually build my base view to start to harvest that metadata. To do that by hitting Create Base View. And what's happening now is Denodo is actually talking to my Oracle database and getting the metadata back for me to interpret, allowing the developer to drill through to the different schemas and tables to import that metadata. We can choose multiple schemas, multiple tables, but for today, I'm just going to choose the one table called customer. Hit Create Selected, and so what will happen is Denodo will harvest further metadata from the Oracle database, data types, indexes, petitioning, etc., etc. Now it's come up to say that I already have a table called customer, so let me just go and rename that. I already have one called 2, so let's go 3. There we go, and the end result is here is that our base view. Once we have our base view, just like in a database, when we create a view, we can run an execution. So you'll see here in the designer, we've got the ability to run a query, limiting it to 150 rows to get the result back. And you'll see that we just get the standard relational result. And this is how it works with all of the data sources that we connect to, in that everything in the Denodo platform is represented as a relational database. And so when it comes time to build a model, we're doing relational modeling. So once you've connected to all of your different data sources, it is time to build that model. So to build our model, I'm just going to, again, go to New. And you can see here we've got the different relational operations to build the model. For today, I'm just going to use the join. When I click on join, we get our blank canvas that I can now drag and drop my base views onto. So in my base views folder, where I've previously harvested all of the base views from the different data sources, I can now drag and drop them. So let's go and drag and drop our store sales. We'll drag and drop our marketing service. It's not the one I wanted. Let's drag our customers. Let's drag our Impala store sales, because that's the historical data. And we finally want the date dimension. So here we go. So we've got our 4 different tables from the 3 different data sources. The next step is to actually join them together, to build the rules about how these disparate data sources connect. So let's join customer to sales. And you can see here we now get a form that allows us to drag and drop the different fields together. So we're going to do customer to customer. Let's now join sales to our marketing service. So here we'll be joining it on promotion code. Okay. And then the last one is the date dimension. So let's join the date dimension to our sales as well. And so we'll join date to date. So what this dragging and dropping has done is actually build the joins. If we go to the join tab up here, we can actually see those described. We've also got the opportunity now to alter or tune these because not always will it be an equal. So we can see by default we've done an inner equal join, but we could change the join style. We could also edit the criteria or add criteria. So I could say, and we can use the suggest equal to null, and so on and so forth. So we could build quite complex logic around how the joins are computed. I'm going to cancel that. The next tab is to set the where criteria. So this is where we're starting to set business rules associated with the data. So if I search for promo, let's go promo equal to 1 and year. We'll go year equal to 2017. I've now set some criteria or a where clause that will run every time someone executes this view. Now I've hard coded these values, but they could be parameterized and passed in at runtime. The next step is group by. Now I'm going to build a view ready for reporting, so I'm going to turn grouping on. If I turn grouping on, Denodo is telling me that it's up to me to specify the grouping criteria. So I'm going to do it by country, by go down to the promo name, and then we'll go down to the date dimension and we'll do it by month of the year. So that's my grouping criteria. When I go to the output tab, we can now add some context, some semantics to this. The first thing I'm going to do is change the name. So here's my marketing report for historical sales. And then other thing I can do is start to change these field names so that they're also more meaningful. So rather than C underscore birth underscore country, let's just make it country. Let's make this promotion. And then let's make this one month. Now we wanted to build a report that showed the amount of sales, but there's no totals on here as yet. So we can actually add a new field. Let's go up to new aggregate field and call it total. And we can make it some of the SS and use control space to give us some more information. And we'll use some of the SS net paid. Now this is using a SQL function, and there's a full library of your SQL date, time, statistical functions available in order to enrich and add fields to your views. Now I've finished. If I click save, and I can now execute a query against it. So if I click execute, what we'll get back is a relational result from those 3 different data sources, regardless of where those data sources actually come from. And there we go. So what's actually happening under the covers? Given that we're only storing metadata, how do we get that data from across the network? So we're minimizing the network traffic and leveraging all of the capability that's available within the information landscape. So given the information we have, the first bit is the query itself. So we can take that query and rewrite it so that it is the most efficient. So removing redundant joins, taking out fields that have no effect on the result, etc., making it as efficient as possible. Then we consider all of the metadata that we know about the underlying tables. Do we have indexes? Is the data partitioned? What is the relationships between the different data sets that we know about? Can we make estimations around what data is going to come back from what system? What are these systems? Are they databases? Are they flat files? Can we create tables, or are they read-only systems? We take all of this data and put it together and come up with some query plans. This isn't the same query, but it's a very similar query. And here we can see 3 query plans. What will happen next is Denodo will cost them out, come up with the cost of executing these plans, and decide on the most efficient cost possible. Or, sorry, choose the plan that has the least cost. So if we take a look at option 1, is where we have the sales system with 300 million rows, the customer system with 2 million rows, and the option is to bring all the data back into the system before doing the joins and the groups. We could say the cost of doing this is about 302 million rows of data movement. So that's our baseline. Option 2 is where we recognize that the sales system actually allows us to create a temporary table. So let's move the customer data into the sales system and then ask it to do the joining and grouping. The result of that is about 52 million rows of data movement. Less cost. Same result. Option 3 is where Denodo is unique. Before we actually start moving data around, we're taking a look at the query to see what the query is actually asking for. And we can see that there's aggregations being asked for. So let's do the aggregations first. We aggregate the sales. When customer doesn't get aggregated, the end result is that we're moving 4 million rows of data. By far the cheapest cost. And so given these options, we would choose option 3. What does that mean? Well, for the consumer, the user actually running that report, it means that they would get their result far quicker with less overhead than using other strategies. We can see this in the tool itself, where for each query, we've got full execution trace to see what's actually happening. We can see for my particular query, I did both a join reordering as well as aggregation pushdown. We can actually explore exactly what was pushed down to each underlying data source by clicking on each data connection here, and we can see that for this Impala system, this was exactly the query that was run. Whereas for each of the Oracle systems, we've also got the query that was run. So full visibility for performance tuning and auditability. So now we've got our report, our view. The next thing is, how does the user find it? Well, our business user would start with the data catalog. The data catalog is a web-based interface that allows the user to log on, again under security management, to find the data that they have access to. So here is the Denodo data catalog. Again, I'll log on as the admin user so that we can see everything in the platform. And you can see as a user, I get presented with a search bar. Now, remembering I'm looking for marketing information, so let's look for everything to do with campaign. We get everything back in the platform that has campaign in its name, in a description, in a field, across the whole platform. I can further refine these results by selecting categories and tags. So this is where my steward or my data owner has actually come in and categorized the data, ensuring that the right data sets are being used for the right purpose. So now I've refined my results. I get back the one view that has campaign data that's been certified for finance use. Clicking on the view, I get all of the information around what this view is used for, what each of the fields mean. I can see the lineage of where the data actually comes from. So we can see promo name comes from our marketing service, country comes from Oracle, so on and so forth. And if I have the right role, the right permissions, I can actually sample the data. I can run a quick query to get the first 25 results to make sure that the data is what I want it to be. So now in the single tool, I can find the data I'm interested in, understand the documentation around it, see where the data comes from, as well as make sure it is in fact the right data, the right values that I want. Having found this data, I could save it away as a query that gives me the option to share my query as a URL. The benefit of this is that now I can share the URL with my colleagues rather than sending a spreadsheet. We're all looking at the same query, the same data set, the same data model, And if my colleagues don't have permission to the data, well, then they're not going to see any of that data. So we're reducing the risk of data actually escaping or being used inappropriately, extending the governance just that little bit further along the consumption chain. So that's the Denodo data catalog that you can see where you can search and find and understand what data is available to you. The next role would be the business analyst. They also would start with the data catalog, but then they would want to actually put that into some sort of reporting tool. We have many technical alliances with organizations such as Tableau and Power BI, Click, Cognos, MicroStrategy, that have included a Denodo connector in their platform. Though if they don't have a Denodo connector, we can still leverage ODBC or JDBC in order to get access to the data. In this occasion, I've used MicroStrategy in order to surface my view. This is just normal MicroStrategy that allows the user to drill and drop and drag and understand the data. MicroStrategy is just accessing data from the Denodo platform, and so it's not aware that the data we're looking at here is actually across 3 different data sources. This also means that there's no need in order to retrain the user or get the user to understand where that data is physically residing in order to be able to use and leverage the results. If we had another user that wanted to use Power BI, it would be as simple as getting them to connect to Denodo, again using the Denodo connector that's included, specifying the connection details. We can use a direct query, and you'll see that the role-based security only allows me to see the data and views that are made available to me. So I can only see my marketing views. So if I choose my view, load it into the tool, again, this is the normal Power BI experience in that I can drag and drop and drill and do everything that I want to without having to build my own Power BI model, as well as even being aware that the data resides in different physical repositories. So I can drag, drop, and build my view. And you'll see that it's exactly the same report as in MicroStrategy without having to worry about where that data comes from. And in fact, I could use any reporting tool that I'm comfortable with to get exactly the same data. So the next role that we'll have a look at is the data scientist. Similar to the business analysts and the reporting users, the data scientists can use Denodo in order to support their data science explorations. Using the data catalog, they can find the data they're interested in. Then using the modeling capabilities, they can very quickly build up the data model, run tests against it, and then go through that iterative process in order to refine and test that model and add new data sources if required, all without having to have additional infrastructure, or without having to copy, in some cases, terabytes of data into new systems and simply to get simply to do some data science exploration. This means that they can deliver an outcome far quicker without having to do all of the data wrangling and exploration and point-to-point connectivity. With Denodo, we've actually included the Denodo Notebook for Data Science that allows you to use the inbuilt to connect to Denodo and explore the data. This notebook's built on the open source Apache Zeppelin, but you could use any tool to connect to the Denodo platform and do your data science exploration. The final role that we want to have a look at is the administration. So we've built a platform that allows our users to connect to data that might reside in Amazon Web Services or on-premise, or even in Azure. a highly distributed complex environment. From a user point of view, they simply access the single platform being Denodo, and Denodo will orchestrate delivery of data from those different systems. From an administration point of view, it's a similar experience. From a single pane of glass, the system administrator can administer the licensing and availability of the distributed environment. So making it really easy to expand and cope with new capabilities. So that's a very quick overview of the Denodo platform that allows you to take all of that disparate data across multiple locations and deliver it up to our business consumers, as well as allowing those consumers to use the data virtualization platform to get access to all of that data without building point-to-point connectivity.